Good afternoon, everyone. I am Maimunuddin, ID 170610. I am presenting our EEE316 Power Electronic Laboratory Project. Battery charger with variable DC output using buck converter with auto cutoff feature. Me and my group mates will describe our project one by one. Now up to you, Shammo.
Thank you, Mr. Maimon. Hello, I am Shojan Dotto Shammo, ID 1706101. Here we can see our charger working principle and workflow. At first, our charger take 220 volt RMS AC input from any household socket. A step-down transformer is used just after the input to step our socket voltage down to 22 volt. Then we will use a uncontrolled full wave rectification circuit to make the AC input to DC voltage. A buck converter is used to produce constant 12 volt DC. Then we will have a battery of 12 volt that will be charged through output of buck converter. Just after that, a cutoff circuit is used to cut the connection off when our battery is fully charged. For simulation purpose, a load like resistor is used to visualize any device. This is our overall charger circuit, where we use some user-defined subsystems. My groupmate Yasser will continue from here.
Thank you, Shammo. This is the input part. In the scope, we can see the household socket voltage of 311 volt peak to peak. Then this is the output of the transformer, which converts this 311 volt peak to peak to 331.1 volt peak to peak. Now the rectification part. Here we use single phase full wave rectifier to convert AC to DC. A filter RC circuit is used to reduce the output ripple and produce constant DC. This is the diode output waveform. Now, the amplitude of the pulse generator is 10 volts to turn the MOSFET on. Now, this part over here is the calculation of the buck converter for its duty cycle, the minimum inductance, and the capacitance. Now we will see the wave shape of the buck converter, input and output. The yellow one, input of the buck converter, is 29 volts. And output of the buck converter, which is the blue line, indicates 12 volts. Now my friend Bishoy will further discuss about the battery circuit.
Thank you, Yasser. I am Bishoy Pal, ID 109, and I will start presenting from the battery circuitry. Now, this is the battery circuit where we have used a breaker for the auto cutoff mechanism. Then we observe the state of the charge, voltage, and current of the battery. And this is the load side for simulating the discharging part. Here we have used the breaker and diode for blocking any reverse current flow. Now we will see the auto cutoff part. Here we have used a relational operator which compares the SOC with the current of the battery. When the SOC is greater than 90%, the charging will be cut off through the breaker. It will then turn on the discharging part. When the supply of current in the battery is over 2 amperes, the discharging part will be disconnected for the safety of the load. Now my teammate Jubair will present.
Thank you, Bishoy. I am ID 1706099. I will describe the charging and discharging part of the circuit. At first, if we see the charging part, let's make our SOC as less than 90, that is 80%. So if you now simulate this circuit, then we will see our breaker display shows 1, this breaker part at the battery, and the breaker part at the load, it shows 0. So that means that our charging part is on and the discharging part is off. So if you see the scope here, we will see that SOC it's increasing. We see the SOC part is increasing. Okay. Now, if we stop the simulation, and for the discharging part, if we make the SOC greater than 90, let's make it 95%. If you now run the simulation, then we will see the battery is discharging through this load. we see the display of this circuit of this breaker shows 0, and this display of this discharging part of the breaker shows 1. That means the discharging part is open and the charging part is closed. If you see the scope, then we will see the battery is discharging slowly from 95% to downwards, and its current is less than it's between 0.5 and 0.6 amps, and the voltage of the battery is also decreasing. So the battery is decreasing. The battery SOC is decreasing here. Now we will see the overcurrent we will see the circuit for overcurrent at the load side. If we make the resistance as 2 ohm, and then if we run the simulation, we will see the display of the circuit breakers. We see the both of the breakers display shows 0. That means none of these breakers are closed, so the charging and discharging part are not working now. Now my fellow classmate Maimon will describe the last part of this circuit.
If we make the SOC at 88.99%, then initially charging should be on, discharging should be off. As soon as the SOC reaches 90%, charging will be off and discharging will be on.
So this is our project and how it works. Thank you everyone for your patience. We are thankful to our teachers for this kind guidance. Any further questions on our project is cordially welcome. Thank you.